The standard normal distribution, Z distribution. Before you work through this video, you will need to know the normal distribution and the empirical rule. If necessary, you should refer to the following video which covers this topic. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. We have already seen in the previous video that the use of the empirical rule can give you a good idea of the probability of occurrence of a value that happens to be exactly 1, 2, or 3 to either side of the mean. But how do you compare the probabilities of values that are in between standard deviations? To solve problems like these, we should use integration to find areas under curves. And the area depends upon the values of μ and sigma. Evaluating such an integral is beyond the scope of this video. However, to help us calculate such probabilities, we make use of a transformation that will convert any normal distribution with mean μ and standard deviation sigma to a normal distribution with a mean of 0 and standard deviation of 1. This new curve is known as a standard normal distribution. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. We can transform all the observations of any normal random variable x with mean μ and standard deviation sigma to a new set of observations of another normal random variable z with mean 0 and standard deviation 1 using the following transformation. To calculate the z-score for any observation, take the value of x, subtract the mean, and divide by the standard deviation. Mathematically, the formula for that process is the following. Keep in mind that the empirical rule is still true. This diagram shows how the new variable z is related to a general normal curve. You can think of a z-score as the number of standard deviations there are between a given value and the mean of the set. While the empirical rule allows you to associate the first 3 standard deviations with the percentage of data that each standard deviation includes, the standard normal distribution allows you to state as accurately as you like just how many standard deviations a given value is above or below the mean. Since z-scores are a measure of the number of standard deviations between a value and the mean, they can be used to calculate the probability by comparing the location of the z-score to the area under a normal curve, starting from negative infinity and going to the right up to the nearest z-score. The diagram shows the area that represents the probability that a randomly chosen value of z will have a value of less than k. To find the probabilities for a random variable x which is normally distributed, we could follow these steps. Convert x values to z-scores using the formula. Sketch a standard normal curve and shade the required region. Use the standard normal tables or a graphics calculator to find the probability. Let's see how it works. Kelly scored 940 on a national achievement test. The mean test score was 850 with a standard deviation of 65. Find Kelly's z-score. The first step is to relate the x value of 940 to the z value using the values of the mean and standard deviation. So, Kelly's z-score is 1.38. Her score of 940 was 1.38 standard deviation above the mean. Find the probability of a randomly selected student has a score less than Kelly's score. We now use technology, or the standard normal distribution table. We find the cumulative probability associated with the z-score. In order to find the values for z-scores, we can use a table like the one below. To find the value associated with a given z-score, we find the first decimal of our z-score on the left, and then the second decimal of our z-score across the top of the table. Where they intersect, we will find the decimal expression for the percentage of values that are less than our sample. Find the probability of a randomly selected student has a score greater than Kelly's score. To find the percentage of the area that lies above the z-score, take the total area under a normal curve, which is 1, and subtract the cumulative area to the left of the z-score. Pay attention. Find the probability of a randomly selected student has a score between 800 and 900. To find the percentage of the area between two values, find the z-scores for each value and subtract the areas. Pay attention.